Hey everybody. So we will do this in class, but in case you're not here, because I know a couple of you won't be here in class, or you just want to come back and hear this again at some point, statistics and psychology. So some interdisciplinary connections. So statistics is the branch of math that concerned with collection, interpretation, data samples, blah, 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 blah. So obviously statistics is going to be used in mathematics. A lot more now in data analytics in regards to like computer science and things like that. Statistics within the field of political science and polling. Statistics is used in many, many different fields of study. So, you know, how it's used in psychology is really important. So, again, with everything we're talking about in regards to how is psychology a science, data analysis, collecting data, being able to interpret it and find meaning in numbers, that is all part of it. So statistics really is used just to organize the data and then find a meaningful way to interpret it and use it, and then make sure that like we are accurately understanding whatever needs to be understood, and things are being accurately represented. So the measures of central tendency, you know these. You definitely know these. Mean, median, mode, right? Hopefully I don't need to explain those too much. But mode, most frequent, mean, the average, median, the middle score. So pretty standard. So based on the data provided, calculate the mean, median, mode of the test scores. What do you think most accurately represents the class overall performance? So we'll do this together in class real quick. So if you're just listening, take a minute to do it yourself, just as really quick, easy practice. All right, yeah, it's 6, 91 to 100, 16, 10, blah, 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 blah. All right, so you should find the average, what is the medium score, and then the most recurring. So when it comes to displaying data in psychology or really anything, or you guys are in AP Stat or your stats, I don't know what level, I don't know. So you get histograms. So they are similar, but they're not the same as bar graphs. They'll be touching sometimes they're not, I don't know, but it doesn't really matter. Or polygons where you see like the connected line graphs. So we're about to talk about how data can be represented and plotted. So which of the following best describes the graph above? Histogram, frequency, polygon, normal distribution, positively skewed, negatively skewed. You might be looking at this and you're like, what is going on? Well, we know it's not a histogram, right? Because it's very much not a bar graph or something like a bar graph. Frequency, polygon, I don't even know what that means. Normal distribution. Well, we know it's not a normal distribution. So normally distributed things, oops, when we have a plot, bang, bang, boom, perfect to see it. A normal distribution is also known as a bell curve. All right, where if you to draw a line, you'd have 50% on one side and 50% on the other, or was it 49.8? You guys get it. So a normal bell curve, right? A normal distribution, that's what it looks like. 50% on one, 50% on the other. Well, we can look at the image here, and clearly this is skewed, right? There's a heavier data set on one side versus the other. So it's definitely not normal. Positive or negative? That's what we're about to look at. So, skewed data, representation of scores that lack symmetry around their average value, right? So in a normal bell curve and a normal distribution, that average value falls right there in the middle, and then 50-50. So there's things that are positively skewed or negatively skewed. Again, that's where the predominant amount of the data points lie in the skew. So the most frequent scores occur at one end or the other end of the distribution. So that would mean, let's say we're looking at test scores. I don't have a eraser here, but we're looking at test scores. So we're looking at 0 to 100 down here. And the chart looks like that. Well, that means, right, a larger portion of the scores fall closer to the 100 range, or on the right, which means means most of the people fell in this regard, did well on the test, because most of the scores are closer to 100 because it's pushed past normal distribution. And then on the flip side, if we're looking at a test again, 0 to 100, and the graph and the distribution looks like this, well, that means the majority of the people did not do well and probably failed the test, with only a few people doing well, but the majority of the scores, right, falling on that end. So positive, negative skew, it's all about where the tail goes. So positively skewed, negatively skewed, right? It's about the tail. It's telling you where the majority of the data points lie. So from here, right, distribution of annual household income in the United States. So, right, it's going to be positive, where you see the majority, that lines up very well, right? The majority of household incomes in the United States are on one end, right? We're not a normally distributed economy or incomes, right? Everyone's different, but most people within the United States fall under 100,000 pretty much, and even more between 10,000 to 65,000, right? The majority of the data points lie there. Yeah. And then an odd bump up here at the tail end, but that still doesn't change where the majority of the data points lie. Right? On the flip side, right, age at death of Australian males, this would also make sense that, right, the older you got, so the further down the line, the x-axis, the majority of deaths would be there. So then it's a skewed data chart, because it's not as though people die, right, at a normal rate, right? It's age. So the closer you get to 100 years old, essentially, right, the more likely you are to die. So it's going to give you a skewed data point, rather than if it was like a 50% normal distribution down the middle. This is that normal curve. So symmetrical bell-shaped curve that describes distribution in many types of data. Most scores fall near the mean. 3 o'clock. Most scores fall near the mean and fewer towards the outliers. And really what you want to then look at is within, this is going to get into like standard deviations. So when you have a normal bell curve, right down the middle. So your standard deviations is like the average from the mean, is average distance from the mean, where scores tend to fall in. So make sure I have my calculator out, so I'm going to do this correctly. So one standard deviation So if the mean, right, is your average, right, your 50% score there, right? One standard deviation from the mean, 68% of all scores are going to fall in that range. 2 standard deviations away. So now all of this, that would be, if I'm make sure I'm doing this right, 87%. Oh wait, nope, I messed that up. It's not 87 because that was 1.5 plus Yes, that makes far more sense. Right, 95? 95% of all scores fall within 2 standard deviations from the mean, and then obviously 3 standard deviations. Is going to be the remaining 99%, whatever it is, not 100%. So, well, 99%. So, this is how a normal bell curve looks in regards to the shape. And then once you start to get into what the standard deviations are, and that's like just the average distance from the mean. So, how you can kind of apply this, if you're curious, like what does this truly mean? If this were a test that we have, like our first test here that's coming, not soon, but that eventually will be coming up in class. If the test was normally distributed, which it won't be because it'd be kind of weird, right? You'd have 0 on one end, right? 100 on the other. This would be saying, and scores ended up falling along these lines, 68% of all tests would fall right in the middle. 95% of all tests, this would be whatever the average is, right? And then 99% would fall within 3. So if the average score was an 80%, and it was normally distributed, and let's say the standard deviation, I don't know, I'm making it up, is 5. Making up the numbers. This would say that, so if 80 was here, 75 to 85, 68% of all test scores would fall between 75 to 85. 2 standard deviations, that would mean 70 to 90, 95% of all your test scores would fall between 70 and 95. And then, obviously, taking 3 standard deviations would go from 65 to 95. And 99% of all the test scores would fall within that range. So that's what standard deviation means. And we're obviously do more of this in class together. So either you're going to hear this again or hearing this for the first time. But hopefully this helps a little bit, being able to see it as well. So range, difference between the highest and lowest test scores, you definitely know what range means. And this is what I'm talking about in regards to what standard deviation. So the computed measure of how much scores vary around the mean score. It just talks about what is the average distance to the mean. You won't need to do the math on the day of the exam. You just need to know what it means and how to interpret it. So we will do a little practice together where you will find the standard deviation just so you have practice doing it. But you won't actually have to do this on the day of the exam. So that's good, right? No math. Inferential statistics sound literally exactly what that sounds like. So numerical data that showed it allows one to generalize or to infer from the data. Obviously, you need representative samples, which means, right, it has to be something that is representative. It has to make sure that whatever population you're pulling from, and then the sample that you're getting from is actually going to be able to then say, you know, like the survey Spelman example. If I wanted to survey, you know, the feelings of boys and girls, like I would have to have the certain percentages of boys taking the survey and girls taking the survey to make sure that it's representative of the larger population. Statistical significance. Perfect. And with this, there's a lot of words on that screen. You need to know one thing. Statistically significant means results not due to chance. Statistically significant results not due to chance. Perfect.